Hello everyone. Today we would be talking about a DSA program, an easy problem but asked in many interviews nowadays. The program is called Panagram. The meaning of it is we would be given a string. We have to identify if the string contains all the letters of English alphabet A to Z. Let's straight away jump into the program and let's see how to solve it. As we were discussing, the program says that we are given a string. We have to return true if it contains all the letters of English alphabet. If it does not, we have to return false. We are also told that the sentence length will be in between 1 and 1000 and the sentence will contain all lowercase letters. Again, this is an easy solution. There are multiple ways to solve this problem. The first way is we create an array of length 26 and keep on adding the character which we encounter in the string to the array's index. Eventually, if we find out that any of the index has count less than 1, we say that the sentence is not panagram. The second option is we create a map with the key as the character and the occurrence of that character as the value. And then we can find out if any of the character is missing in the map. The third very interesting way would be to add the ASCII code of every unique character appearing in the string minus 96 as the ASCII character of A starts from 97. At the end, we will see if it matches the formula of arithmetic progression, which is n into n plus 1 divided by 2. Today, we will be talking about another way of doing this. To talk about the fourth technique, first we have to understand the requirement here. Is it asking us to find out the number of occurrence of each character in the string? No. So why are we worried about storing the character and the count? What panagram means is every letter of the English alphabet should be present in the sentence, which means we need to have only 26 iterations where we have to find out if the character is present in the sentence. And this is the fastest solution. Let's understand how to do it. This is a classic example of perspective. Till the three solutions that we talked about, we were always looking into the string and we were trying to find out if the string contains the character. In this process, the iteration is actually the number of characters present in the string plus the iteration of the array map formed for the characters to find out if anything is missing. So instead of going through the sentence, we can directly go through this 26 character and figure out if anything is missing. This is how we eliminate the unnecessary step. So let's try to solve it. Before even jumping into this program, we can directly write if the length of this sentence is less than 26, it's not a panagram. Once we have got rid of the base case, let's write the code for the program. We talked about the loop for 26 iterations. Now we have to iterate through each of these characters and find out if the sentence contains these characters. To perform the operation, we will make use of a method present in string, which is index of. If a character which we are searching for is not present in the string, the index of returns -1. We will make use of this feature. So in the string sentence, we will see if the character is present. We can safely say the character is present in the string if the index is greater than equal to 0. So if it is less than 0, we can say that that particular character is not present in the string, which means we can break the loop there itself and say it's not a panagram. And if we come out of the for loop, we can return true. Let me explain you the solution again. The base case is pretty easy. We are just checking if the length of the string is less than 26. In the case of lead code, the length is less than 26. So we can directly say it's not a panagram and hence return a false straight away. Coming to the next part, the loop. We are traversing through every character starting from A to Z. How are we doing it? This lowercase character A in ASCII is represented by 97 and B by 98, C by 99 and so on. So we are iterating through these characters A to Z or the ASCII value of it, which is from 97 to 122, and we are checking if this character is present in the string. So once we have started the loop, we go to the sentence and find out the index of of these characters if the index is greater than equal to 0. If it is not, which means it has to be less than 0. And we discussed that the index of any character which is not present in the string is -1, which is less than 0. So whenever we get the value -1, we return a false. If we come out of the loop, means that we have discovered every character of English alphabet, which means the sentence is a panagram. If I execute this code, because it is a string, we need to have parenthesis. After resolving the error, if we execute the code, we will observe that both the test cases have passed. And on submitting it, we see that the runtime is 0 millisecond, which beats 100% of the users. That's all for today. Thank you for watching the video. I'll come up with some interesting topics again. Till then, happy coding.